how we get from here to a fraction. Awesome. Very, very good. So x is present in all three terms. I would factor out x to negative 3/2 because x to negative 3/2 has the smallest power. So I have negative 4, negative 1/2, remember negative 1/2 minus negative 3/2, this is 2/2, which is 1. So plus 1/2 f of x. And now from 1/2 I subtract negative 3/2. From 1/2 I subtract negative 3/2, so this will be 1 and this will be 2. So plus x squared f prime of x. Very simple. See follow the triangle, and this is x squared f prime of x plus 1/2 f of x minus 4 divided by the square root of x cubed. Now if you want not even to have 1/2 in there, that's fine. Then I would have 2x squared f prime of x plus f of x minus 8 divided by 2. And if they want us to simplify that, we can also simplify that. So I don't know how the answer is presented. If it's a combination of these two, I'm not sure. I'm not looking at the problem, so I have no idea. But this has to be accepted. Mandatory. This has to be accepted as the final answer. Or if they want this instead of this, then you have the square root of x cubed. That's the only difference. So either the square root of x cubed or x the square root of x. I don't see any of the answers. So which one is it? Which one do they accept?
So for you to compare the two?
Yes. So accept this.
I mean, sorry,
Okay, let me, I have WebAssign open in the background because I needed the book anyway, so allow me to go there, and I am going to go to the problem.
Yeah.
So it was,
it's the same. It's just you've written it in a different order, so it's fine. I think you've done all the work, Chris.
So it doesn't matter. This is the correct order, but they may want f of x minus 8 plus this, or this in the denominator. It doesn't matter. So who was that? It was Casey?
Sorry, that's Chris.
Chris, sorry. Okay, I'm going to your question exactly, because everybody gets a different question. I thank you so much for bringing these questions to class, because now is the time to clarify everything in this section. Okay, and you said that this was coming from 3.2. Awesome. I just clicked on it, and you said that was problem 16. Very good. I'm scrolling to 16. Okay, and you said it's part D. Yes, so they just twisted these two, and they wrote the denominator with powers instead of the square root, right? So this piece is the same with x to 3/2. This piece is the same with x to 3/2. And they just reverse these two. So it's as you selected, number 1. This should work.
Yes.
Okay, well done. Yeah, I would have to agree that this is a little bit of a weird situation, but we encounter these, so. Awesome questions. Anyone else needs help with anything? Anyone else? Okay, you can always stop me if you find something else. So let's go back and finish up the section 3.3. And we had looked at that limit, and we have to look at one more. So I'm going to share my screen, and I'm sharing my screen right here, and this is 3.3. And we went through all these types of problems. We determined equations of tangent lines. We did that last time. Now I would like to continue and look at more limits. I don't remember right now which limit. I think, oh yeah, the one with 3x, something like that. This one, yeah, we did that. Okay, so let's look at 53, just as practice. So 53 is limit as x approaches 0, sine 3x divided by 5x to the third and minus 4x. Perfect. Can anyone tell us how to start? What do we need to do first when it comes to limits?
Plug it in.
Yes, awesome. Thank you so much. Can anyone tell us where is the numerator going? Because this is the tendency of this function, right? That's why we're asking about where are the values of y going when x approaches 0.
0?
Yes, sine 0 is 0, perfect. What about the denominator?
0.
Yes. You could say L'Hopital's rule, not yet, because we need section 3.4. In this particular case, we cannot. But otherwise, after 3.4, we can. It's 0 over 0, it's a limit. Condition, the first hypothesis is fulfilled, the second hypothesis is fulfilled, we can. But not this time, because we have a function of a function. It's not plain x. Okay, so then let's take a look at this one that cannot be changed in any way, shape, or form. So that little box that I like to call, that little box or rectangle, is 3x. When x approaches 0, where does 3x go? Yes, of course. Thank you so much. Now, let's analyze what we should have in the denominator. Don't even look, I don't care what's in there at this moment. Well, what should I have in the denominator to conclude sine of 3x when 3x approaches 0 over this is 1? What should I have in here? And then we'll see if we...
Also 0.
Careful. So sine of the rectangle, when the rectangle approaches 0, and the denominator must be?
3x.
Yes. Okay. I have some gibberish here, but I see that there is a common factor that I can pull out. Which is the common factor that I can pull out here?
X.
Yes, awesome. What is left in parentheses?
We can't see.
Yes, I just saw that. My camera has a mind of its own. What can I say?
5x.
Yes,
5x squared minus 4 is
5x squared minus 4. Awesome. Leave it alone for a moment. I'm going to rewrite it because I don't want to overwrite out of it. So we have limit as x approaches 0, and we know that this also means this. I can put that in parentheses. I have sine x at the top. I have x, and I have 5x squared minus 4. Good. Stay with me. Leave this alone. One more time. What do I need to have in the denominator? Mandatory.
3x.
3x.
Yes. I multiply the top and the denominator by 3, which means 1. I did not change the problem. If I only had this, 3x approaches 0, sine 3x over 3x, what would the limit be?
X. 1.
Careful,
0.
careful.
It'll be sine of x.
One more time. Sine of the box over the box when the box approaches 0. Where is this going?
One
Good. Times,
times 3.
okay. So then the numerator goes to 3. Can anyone now tell us where is the denominator going when x approaches 0?
Negative 4.
Thank you. So the limit is negative 3/4. So remember the condition. sine 3x over 3x, when 3x approaches 0, this piece, just this piece, approaches 1. But I still have something else left over. I have a 3, and when x approaches 0, the denominator approaches -4. I cover this with my little props because this is 1 now. And I should have covered this too. But I didn't have 3 little erasers. Okay? So we made it happen. We had 3x. We made it 3x. There is no problem. When I multiply and divide by 3, I make no changes whatsoever. This is 1. But then these go away because this will approach 1, but I still have leftovers. The leftover from the numerator is 3, and the leftover from the denominator is -4 when x approaches 0. So therefore, the limit of sine 3x over 5x cubed minus 4x as x approaches 0 is -3/4. Questions on this, or we move on? You can always stop me if you remember something else. Okay, I'm sharing my screen, going back to the problems. Okay, I wanted to also discuss this limit, because there is one more rule and then we can move on from this. I think we had enough. So let me just copy that 57. Unless you feel like working on others. Okay. So this is the other limit that I would like to discuss. We already have one. We have the limit as the box approaches 0, sine of the box over the box equals 1. And also the multiplicative inverse, the same thing. So limit of the box approaches 0 from the box over sine of the box approaches 1. But we have one more, which is the limit of cosine theta minus 1, or x, it doesn't matter, as theta approaches 0 divided by theta. But this limit is 0, and it has to be remembered like this, meaning the limit as the box approaches 0 from cosine of the box minus 1 over the box, this is 0. We can prove this now, and we can prove that too. We did that last time with L'Hopital's rule. Let's prove this. So we have the limit as theta approaches 0 from cosine theta minus 1 over theta. When we determine a limit, what is the first thing? I know I sound like a broken record, but it's the only way to embed this in your system. So what do we do with the limit?
Plug it in.
When we plug it in, what do we get at the top and what do we get at the denominator?
0 on the top.
Yes, because it's cosine 0, which is 1, 1 minus 1 is 0, and 0 in the denominator. I have the limit, I have 0 over 0, I can apply L'Hopital's rule. I have to copy the limit operator, it does not disappear. Can anyone give us the derivative of the top? Remember, we never do this. This is a quotient. We never differentiate top and differentiate bottom. We have a specific quotient rule. But when it comes to a limit, when the initial assessment is 0 over 0, then we can. We never ever do that otherwise. So can anyone give us the derivative of the top?
Negative sign.
Okay, awesome. And the derivative of the denominator?
1.
Perfect. Can anyone now plug it in and tell us the answer? Anyone?
0. The answer is going to be 0.
Of course, because sine 0 is 0, 0 over 1 is 0. Okay, so now let's come back to 57, and I think we had enough.
Did you get the 1 in the denominator one more time?
The derivative of x, or the derivative of theta, is 1.
Okay.
Perfect. So then limit, as theta approaches 0, from cosine x minus 1 divided by 2 theta squared. Yes, we can apply L'Hopital's rule here, because it's 0 over 0. But let's apply this limit. So I do have the box, I do have the box at the top. I do have the box here. But I only need the box. I don't need 2 theta squared. I just need theta. I will separate it. Theta approaches 0. Cosine theta minus 1 divided by 2 theta times theta. So what do we do?
Plug in the limit.
Okay, careful. So we have theta approaches 0, and we have cosine theta minus 1 divided by theta. Where will this limit go?
0.
Right. So this will be 0. But where is this going? When
Also 0.
also 0. So it's a little bit of a question mark here, what we conclude, right? So let's go back for a second. So if we use L'Hopital's rule, because the numerator cosine 0 is 1, 1 minus 1 is 0, the denominator is 0, limit and 0 over 0, both conditions are fulfilled, I can apply L'Hopital's rule and let's see what happens. Limit as theta approaches 0. You already told me that cosine prime was negative sine theta. We will differentiate this. Can anyone give us the derivative of 2 theta squared?
4 theta.
Okay. So now, what happens next? We can plug it in again, and we know that sine 0 is 0, 0 over 0, right? But we also know this. Box approaches 0, box, or rectangle, I don't know how you want me to say it. What is this limit?
1.
Yes, but we have some left over. So then what is the limit?
Negative 1/4.
Negative 1/4.
So, I guess, did we need to apply L'Hopital's halfway through?
Well,
how do we get?
So no, we didn't apply it halfway through. I started it from scratch. So this was the original problem. I started from scratch.
Right. Okay.
We did not
Can
apply
Can it be
no.
solved the other way?
So I put the question mark here because we are running into a problem. That's why I said, okay, I have right now 0 over 0. Because this approaches 0 and this approaches 0, right? So I'm back to 0 over 0. I could have used L'Hopital's rule, but from here, because I will just go back and multiply. Instead, I just went back to from scratch. I didn't have to do any of that. Because the thing is that we need to further manipulate this expression. But instead of doing that, it was better and easier to do this. How do we do this? Okay. Because I don't want to just wave my hands. I just want to explain. So in order to continue like this, we had to use an identity, a trig identity, for 1 minus cosine. So 1 minus cosine theta, not cosine minus 1. I have to distribute factor out negative 1. This is 2 sine squared theta over 2. So since we're here, I have to show this. Okay, you don't have to use this method because we have now L'Hopital's rule. But let me look at the time. 19. Is it 19? I think so.